Hi, and welcome to episode 4 of the eCHO live stream, eBPF and Psyllium office hours. I can see a few regular guests already with us, which is wonderful. So, hi to Magno and Pratyush and Marino and Michael. Marino, I loved your tweet that was helping us promote this particular episode of eCHO. That was really appreciated, so thank you. Oh, and Grant, Christoph, welcome to all of you. Right, without further ado, I would really like to introduce our very special guest, and I'm hoping that, yes, my Zoom and streaming setup has worked. So, giant round of applause virtually for our special guest, Kris Nóva. Welcome to eCHO. And welcome to
Hi.
the most beautiful dog in the world.
Yes, yes. I figured we would bring Bjorn on for his special premiere debut of CNCF KubeCon with Kris Nóva and Liz Rice, starring Bjorn the dog.
Bien the dog is just so cute. I think I could spend my whole life on Twitter looking at really, really cute dog photos. We should try not to
Yes,
talk
yes.
about dogs all through the show, but there we go. I'm just gonna quick housekeeping thing. As always, folks, if my sound setup isn't right, just let me know and I can adjust it. All right, so I can see a few people waving hello, and yeah, you've gone a bit out of focus there.
Yeah, let me see if I can refocus.
All right, tell you what, while you're sorting that out, why don't I just talk a little bit about the news that's been happening in the world of eBPF. So one kind of interesting thing comes from the world of Windows. Now, I have to admit, I'm pretty much, I'm aware that there's an operating system called Windows, but it's not my speciality. But apparently, Procmon, a process monitor, is a big thing in Windows, and Microsoft have just released a preview of a Linux version of Procmon. So that's pretty cool, and it's eBPF based. Another bit of eBPF news was from, don't want to subscribe to ZDNet, was from New Relic, who acquired Pixie, I think, towards the end of last year. And they've open sourced that, which is very exciting. And it's kind of observability based on eBPF. So it'd be really cool to see how that project progresses. The third link I wanted to share, and this is an amazing roundup that our colleague Quentin puts together on a fairly regular basis, and he's collected together loads of really cool news and blog posts and just updates from the eBPF world. So if you're not already checking out eBPF.io, definitely go and look at these updates, because he does such a great job of collating together like what's going on in the eBPF world. Also going to just give a very quick shout out for our colleague Beatrice here. She is taking part in Continuous Lifecycle Online next week. So that should be really well worth seeing. Folks there from the BBC as well, which is kind of cool to see if they're using Kubernetes. I'd love to know. The last of this little link section, and I loved this today, we have like a prototype bumper sticker for eBPF. So my other sidecar is a kernel. I'm hoping somebody's going to actually turn that into stickers. That would be so cool. I don't know. So, Nóva, welcome to the show, and welcome to this whole eBPF and Psyllium office hours. How are things with you?
Things are great. Living
Yeah,
the dream, loving life right now.
particularly with your beautiful Björn the dog. That's amazing. You joined Twilio. When did you join? Was it earlier this year, wasn't it? I mean, can't be in the
Yeah,
future,
it
surely.
was, let's see, January, February. I think it was the beginning of March was my first day at the company, and I think I kind of knew Twilio was gonna be winning earlier this year. So I mean, it's still pretty new, pretty fresh.
And what kind of things have you been working on? If you're allowed to share that kind of.
Yeah, I can. I would love to share. So this is like probably my first time of really kind of giving a lot of insight into what I'm doing at Twilio. So I've moved over from more of a public facing advocacy style role, and here I'm back to just good old fashioned engineering again. And it feels really great to be back on an engineering team and working on some concrete problems, all of which are directly revolved around cloud native and a lot of the tools in the ecosystem. So it's been really interesting to go from being a public facing persona to an actual end user practitioner that's dependent on this. We have real production services, and we're using a lot of cloud native tools internally, and I'm trying to solve some problems for the business around that. So concretely, what we're doing is we have a really simple problem that, of course, becomes a challenging problem at scale, which is we need to run a lot of services, and we would like to run them on bare metal. So really, what we're doing is Kubernetes on metal, and Kubernetes in our own data centers, and looking at this kind of from the ground up, and how do we build that infrastructure, and using tools like obviously Kubernetes. We're really dependent on Argo. We use that. I mean, I'm looking at an Argo dashboard like every day. And then all of the fun nuances with the kernel and user space and eBPF, and what does our at scale bare metal distribution look like. So that's been really fun and exciting, and that's really what I'm working on here, which is, it's a good space for me to be. I'm really happy.
Awesome. And when you say scale, I mean, Twilio is kind of almost telco scale. It's huge, right? I don't know if you're allowed to share anything about the size of network or Kubernetes clusters that you're working with, but definitely huge from what I hear.
It's huge. And like, I think that's one of the things about Twilio is we are a really big company, and I work at a small part of the broader picture. So I'm really coupled with what used to be called SendGrid, which is an SMTP based company out of Denver, where I used to live. And I'm working with some of my old colleagues from Denver, and really our bread and butter is email. And like anything at scale, there's a lot of nuances with that. And so that's really what we're focused on. And we don't really even touch a lot of the other, more like, I would say, conventional parts of the company. There's other folks focusing on that. And like, we're just dealing with large scale metal deployments. I mean, if you look at, any of what I would consider like the modern stack management, we're having to deal with that, across the globe for email. So that's just an exciting problem to look at. And I don't know exact numbers off the top of my head with, network size or how many nodes we're running, but I can tell you that we've reached the point where entertaining the idea of building management tools with cloud native to manage other management tools, if that alludes to the size of the problem space we're dealing with here.
And so you're using is it exclusively bare metal, and are you doing sort of interesting things in terms of managing Kubernetes on bare metal?
So really Kubernetes on bare metal is a means to an end, right? Like it's keeping, how do we approach solving real computer usage problems? Like, we have a ton of compute. We have a lot of emails we're having to deal with, and there's nuances with SMTPD. And how do we push that through metal, and how do we keep costs down? And when you just run the basic arithmetic with something like, Amazon or Google, or, some of the other places I've worked even, just from a cost-effective standpoint, metal is a means to an end to just keep that cost down. And so then, taking that a step further and saying, okay, Kubernetes, now what? How do we look at managing Kubernetes on metal? And I mean, and if you read my book or look at any of the work that I've been doing over the past 4 or 5 years, like the fact that I'm here probably makes a lot of sense. There's a lot of assumptions we make with the cloud, which is like we can click a button and get a server. And that's just not the reality when it comes time to screwing pieces of metal into a rack. So looking at writing software to manage things that don't necessarily always yield software compatible inputs and outputs. And that's a big part of what we're trying to tackle here. And then how do we still give ourselves all of the lovely user interface and economic perspective of the cloud native ecosystem while still managing screwing servers to a rack at scale?
So, important question. And well, let me just mention, audience, if you have questions, do type them in. I will try to relay them, and I think Nova has them on screen as well, so we can see what your thoughts are and what your questions are. But Are you getting to do things with eBPF in your current role?
I am. It's an interesting problem space, and like anything that we do, I'm a very big advocate for defining the problem space first, and then entertaining the list of possible solutions. So eBPF comes up as a possible solution all the time. I mean, if whether we're looking at high level networking concerns or high level network management at scale across multiple subnets, eBPF is top of mind. Whether we're looking at security and how do we look at what's happening at like the three pillars of computer science on a piece of metal, right? Compute, storage, and network. Like what does that introspection and that observability look like? And yet again, here we are with eBPF. And then even the operating system itself. That's something that I've been putting a lot of work in open source with the new Cosy project that we've been working on, kind of outside of my day job, which of course you know what it's like to try to keep open source and a neutral standpoint balanced with your day job as well. And all of that kind of yields around eBPF as a tool that we would use to solve a lot of these problems that I think folks are facing every day. And yeah, like I just look at eBPF as it's a platform on which we could start building higher level tools. And it really reminds me of C groups and namespaces, circa 2015, like those same, like we can build containers and that technology is enabling these new exciting conversations. And I just feel like eBPF is that same level yet again, but 2021.
Yeah, and you've been involved in eBPF related projects for quite a while. So I think you're one of the people with experience in this space, right? So Magno's asked, what's the next cloud native security tool that you see eBPF being used as an engine, and why? Kind of interesting question.
The next cloud native security tool so I don't know if I would see an engine that has yet to exist that would use eBPF for certain things. So to me, when I hear engine, I think of some sort of processing daemon that's important to humans, and eBPF just gives us that, quasi-Turing complete ability to do things in the kernel that we wouldn't be able to do as effectively otherwise. And then security, like I mean, Liz, you wrote a book on security. There's so many like aspects of what does security mean to you? Is it how do we prevent things from happening? How do we respond? Is it the post-mortem? Is it detection and forensics afterwards? Like where does security start and stop, and what does that whole story look like? So I don't know what the next security tool is. I think my posture always is that having one security tool is a good first step, but having multiple security tools or avenues is a better step. So I don't know if we're ever going to exactly. I don't know if I'll ever see one tool to rule them all, just like we don't really have like anything to rule them all in cloud native. The whole point is we have an ecosystem here.
Yeah.
So that's my philosophy.
I mean, for sure, there's like eBPF is a very useful building block for a ton of things related to security, and and particularly that kind of forensics. The fact that you can pretty cost effectively get hold of a ton of cost as in performance, get hold of tons of information about what's actually happening and send that out to a sim, and then if something bad does happen, you've got forensics. I feel like that's one example where eBPF is really well suited. And an example where it would be terrible would be like image scanning. Why? You just, it wouldn't be a good hammer for that particular nail, I think. But hey, we've got Duffy on the chat. Good morning or good afternoon from me, but
yeah. Hey, Duffy.
Yeah. Oh, yeah. We so Duffy's pointed out that we both have Heptio. So Nova is like a proper official Heptio. You're entitled to it. I have some Heptio posters because Duffy gave them to me, which I very much appreciated.
So like a proper security researcher, these pillows that you see were acquired, and I'll leave the story there. But yes, I was very proud of Heptio, and I had an opportunity to bring some of it home with me, and I very much love that I still get to see the things that brought me so much joy in the past still alive. So I'm glad somebody noticed.
I feel like I can kind of show you know, I also have
Yeah.
branded pillow, so yeah. So hopefully, this came up actually on Twitter this week that you know, we will have a swag store soon, so people will be able to get hold of their own Psyllium pillows.
Oh, I would love to get some Psyllium swag.
We
So
should
like why we're
definitely send you
here.
something. You definitely get some swag for being on this. We're gonna have to figure that out for sure.
That I absolutely love Psyllium, and I've been an advocate for Psyllium for so long. The fact that you're here just made me so excited.
Oh, thank
I
you.
just I love it. CNI has always been hard for me, and like I just Psyllium has just kind of scratched that itch with eBPF that I've always wanted to see, and I feel like it was done really well, just kind of from the ground up. So it's really exciting to be here, and after kind of following along, I feel like it's like following like the local small town band who like made it big. Like I
Yeah.
had the T-shirt, originally, so it's been cool.
Yeah, yeah. I mean, it's such a good time for Psyllium from my perspective. You know, now that kernels are running that are eBPF capable in, you know, most people's environments these days, it's really, you know, a great time for eBPF based tools such as Psyllium. I see some more familiar faces or names at least on the chat. Hi, Lewis. So I don't know if you had a chance, Nova or any of the guests, I was going to say SIG security, it's now tag security. They have Cloud Native Security Day as part of KubeCon, and as part of that, they had a CTF. Lewis was the taskmaster for that CTF, and I think he did an amazing job. So well done, Lewis. That was probably a highlight, I'm going to guess, for a lot of people who managed to do that CTF. It was. I didn't get to actually do the CTF, but I got to kind of participate in a little bit of a panel, like an online discussion about CTFs, and yeah. Lewis, I think, was managing a lot of Kubernetes clusters that were being hacked into. Which I think, did you
cool.
recently do like maybe a clustered, like with raw code?
I did this yesterday. We did clustered, and this was my first time on the show, and I didn't really know what to expect, but it was, I had a great time. Yesterday was a ton of fun.
I think, you know, hacking clusters is always good fun. Always good fun.
Yeah.
Oh, I can see Lewis saying thank you. That's nice. Great.
That's awesome.
So I've kind of messed up my screen arrangement in an attempt to get you and me on the screen, and now I can't see my notes, so I'm going to just have to go on the fly. It'll be fine. So one of the things I was going to try and talk about today was some of the kind of how there've been a bunch of eBPF talks at KubeCon. The links to those are going to be in the notes, so we don't necessarily need to talk about, you know, we don't need to do like a review of every talk. But I think some of the interesting things that came up, I mean, we were just talking about hacking Kubernetes, and there was a talk, not really eBPF related, but did you catch or see on Twitter Tabby, Sable, and L Corbez's Hacking Kubernetes 101 talk? I don't know if you saw it. It was briefly setting Twitter on fire, I would say.
I haven't looked at it at all yet. I've been kind of detached from the actual conference events. I plan on going back and maybe watching some of the videos, and I think that one, a few folks have mentioned it to me that I plan on looking at. But I mean, if you saw it and you could tell me about it, yeah, I would love to hear more.
They have set the bar for like production values for conference talks super high. It was like a proper movie. They had characterization, they had amazing camera editing, and they had like a really good kind of story of someone kind of behaving badly in their Kubernetes cluster, and how their kind of, I can't remember what they called it, like DevSecOps command and control or something, you know, was like a character tracking down this person who had done bad things in the cluster. Yeah, there's a few comments on it about yeah, how great, that best Kubernetes security talk ever. I think that's probably true. So definitely worth checking that one out.
Oh, that sounds so cool. I'll make sure I watch it.
It really was good, and it was it was a whole other level in terms of like camera work, scripting, everything. Really good. Magno saying, I'm kind of worried now to submit my talk for KubeCon, and I know, I think we're all going to have to like up our game if that's the new level. Yeah.
Well, I've got the doc pulled up on my screen, Liz, and it looks like there's a few talks here. There's eBPF on the rise from Quentin. Looks like Leo and Leo did a Falco. Oh my God, are these the talks that you were mentioning earlier?
Yeah. I will shout out for Quentin's talk, because that was a really good introduction to eBPF. So Quentin works with us at Isovalent, and he's also the same person who was responsible for that like summary of eBPF updates. And the really cool thing about his talk, I would say, there were many aspects that were cool, but the number of people who were engaged and interested and asking questions about eBPF, it's definitely it's a technology that is striking interest in with a lot of people. I think people are sort of recognizing how powerful this is going to be. Things like that bumper sticker that Nathan's come up with, people really recognizing that, also JBD getting involved with Pixie, and she's saying, she's doing some really insightful commentary about eBPF and how it's such a good platform for observability, and I think that's kind of what we've been seeing here in the Psyllium project as well. The networking, observability, security, it's good for all these things. Okay.
Absolutely. So it looks like in the doc there was a few other ones. Looks like Lorenzo did the art of hiding yourself. There's one on Falco.
Yeah, that was actually a really interesting talk. He was talking about how assume that you have already compromised a pod, or you've got yourself root access on a cluster, or on a node rather. How would you hide your tracks? How would you make it hard for someone to know you'd even been there? So he was talking about hiding processes so that they're not visible in PS, and removing information about a pod from etcd so that if you looked at the running pods you wouldn't see it. So that was actually a very, very interesting talk that's made me sort of want to go and look into some of the detail. He didn't cover all the details, so I'm definitely interested to see how some of those details are achieved. But yeah, it was a good talk. I remember there was another one that I want to give a shout out to, which was Jed from Tesla and another Isovalent colleague, Natalia, talking about essentially eBPF in Kubernetes security, and they had a really great demo showing kind of performing suspicious activities in a cluster and how that could be detected with some eBPF tooling. So it's similar kind of things to like Falco detection or Tracy detection, looking for security related signatures, we could say. That was really good. Yeah, I've seen some nice comments about Lorenzo's talk was 100. Yeah, I never know how like you're supposed to read the 100 emoji. Like just let's say 100.
Yeah, I always read it like 100%, like a perfect score you would get on, like a spelling quiz or something.
I nearly said 100%. Yeah. Okay, and we've got some links going in for Ellen and Tabby's talk. Yeah, that was great.
Great.
So you mentioned earlier that you're working on this common operating system interface, and I think there was a talk about that as well. So I think, was it Andrew from Talos who you're working on that with? I think he did a talk about it, which I only managed to catch the first few minutes of, and then I got pulled into something else. But yeah, so tell us a little bit about this Cosy initiative.
Yeah. So this is, how can I put this? Where do I even start? The operating system has always been frustrating for me in Kubernetes for many reasons, particularly this for the exact same reason that infrastructure has always been frustrating for me. Is it's kind of an ancillary concern that I feel like in some ways is often forgotten about or overlooked. And really, like, a lot of the work I did with, clusters as a service and setting up, Kubernetes clusters with tools like kops and KubeCon, and helping to get cluster API off the ground. All of this was kind of a reflection of, like, I'm tired of infrastructure being the part in my engineering story where I have to, like, say, hold on, wait a minute, this is going to take some time, and this is like a bit of a problem. I kind of just wanted to have that finalized once and for all. And over the past couple of years, the operating system became that new kind of like point of friction for me, which was anytime I was looking at any sort of security boundary between a Kubernetes pod and the host, or I guess I should say lack thereof, the operating system always felt to me like it was kind of like included into the rest of the workflow as needed, and we never really took a holistic approach at what should the operating system look like if we plan on running distributed workloads with containers. In my mind, like, the kubelet is monitored with systemd usually, and it's like, yeah, we can monitor a service like the kubelet with systemd, but what does that mean for the rest of the operating system? And if you look at the three pillars of, compute, storage, and networking, like, the container runtime, CNI, and CSI, they all kind of approach the operating system differently. Like, CNI, like, privilege escalates to the host and then, like, tries to set up the network. But if you look at the install story for CNI, like, you need a Kubernetes API server up and running, which means you need the network to route to the API server to then install host level networking concerns.
Yeah.
And so it's just felt a little kind of like, it felt a little uneasy, I guess. And anyway, Cosy to me, before I started working with Andrew, was just, what should it look like? If we were to build guardrails around what we want the operating system and the host and with tools like eBPF to look like, what should it look like? And then, Talus appeared in my life, and they were kind of working on the same thing. And Andrew and I got together and started talking and realized we had both written like a PID1 kubelet alternative independently of each other. And we said, okay, we should look at forming some sort of open source initiative here around a lot of this. And thus the Cosy project was born.
Brilliant. So explain how this is, like, how would this relate to something like, what used to be CoreOS, and I think it's kind of evolved into Flatcar Linux now, but like those kind of container specific operating systems, well, how would that relate to something like Cosy?
So in my mind, CoreOS did a really good job at using containers in ways that, like, really truly using containers as a building block. And I feel like containers are a good building block, but I think, again, like eBPF, it's a means to an end. Like, just because you can run everything in a container doesn't necessarily mean you should, but it is a good tool if used effectively. And so for me, CoreOS or Talus would just be a concrete implementation of some sort of operating system set of concerns. And really what I'm trying to get at is kind of the same thing we did with Cluster API. It's the same thing we did with Kubernetes. It's the same thing we see all throughout cloud native, which is the API is what's important. Whether or not your PID1 is systemd or a container, or you wrote it in Bash, or you invented your own programming language from the ground up, is kind of ancillary to the fact that it should still just fit into a convenient standardized interface so that it can talk to other components of a distributed system. And I mean, this is just human arrangement, right? Like POSIX had tried to attempt at this, 20 plus years ago, and we have standards in everything we do. And I think this is a very, like, container distributed systems look at what should an operating system look like. Whereas I feel like Unix traditionally is what should an operating system look like for a human being in a workplace who needs to do time management and scheduling with a limited set of technology and a limited set of bytes that are available to us. And I just don't think we're there anymore. And it's been great that we could build on top of this, but I don't know if we should still continue to do so. And that's my very crazy idea here.
And would that operating system that meets that definition of the interface, would it necessarily be a Linux or Unixy operating system, or could it potentially be like Windows working to this interface?
I would love, I would love to see FreeBSD, Windows. I mean, honestly, if we could live in a world where you could change out your underlying operating system, like you change out your container runtime, that would be fabulous. And then like there's trade-offs with these, right? There's support packages, and there's security concerns, and maybe in one you optimize for like highly distributed but like ephemeral operating system PID1 style experiences, and then the other it's more of like a small time, on the edge Raspberry Pi system on a chip style. But like the idea is that if we're building standardized interfaces for this, we should be able to kind of continue to use a lot of our other work on top of it. And so like I think Linux is a great example. The kernel community is interesting to say the least, and I think that they've already put a ton of work into C groups, namespaces, how do you look at mounting block devices, the device tree. There's all of these wonderful kernel primitives that we have, and I would imagine that we're going to continue to celebrate a lot of those primitives in what we're considering the common operating system interface.
And would something like eBPF be entirely orthogonal, or would that be potentially a dependency, or like no?
No, absolutely. Yes, eBPF. I think eBPF is, I don't think we would be having this conversation if it wasn't for eBPF, which would be, now we have a runtime safe virtual machine in the kernel that we can build almost Turing complete logic into, and we can build that proprietarily for arbitrary use cases, and we can dynamically load it at runtime. So now where it's like, let's take eBPF and let's run with it. Let's really explore what metrics we care about in Kubernetes that we could get from the kernel, and let's build little building blocks for that instead of trying to like shoehorn together, continually wrapping layer after layer after layer on top of each other. If really all we care about is our load average in Kubernetes, like let's get it, and let's get it well, and let's put it into a standardized uniform face that anybody can consume.
So we're getting a few questions here. One from Suresh talking about would you compare it with Rancher OS or Fedora Core OS? But I think that's similar to that. Question probably came up before we talked about other kind of container-oriented operating systems. Magno asking, what about GKE Autopilot? And I'm going to admit I am not familiar with what that is. So I don't know if you know what it is.
I think, isn't it just like I hate doing this to cloud providers, but I've also worked at a few of them, so I'm going to do it because I feel like I've had it done to me in the past. But I think GKE Autopilot is just the Fargate alternative to Google, right? It's just a single container runtime. It's like a kind of like a workload deployment engine, if you will. Again, I think like if we're looking at a bare bones minimal operating system that's standardized, and you can start to like piece together the different components of your operating system, like you would piece together, a Kubernetes distribution, I would see all kinds of interesting tools and resources like GKE Autopilot coming out of at least standardizing some of these components.
Right.
And I think that it's a very simple concept, and it's not anything new. It's just more or less kind of, it's a bold statement to make, I think, to say something like we should be able to standardize components of an operating system.
And Michael is suggesting that Cosy could be a way of defining an interface that an operating system would provide so that Kubernetes can function well.
I think Cosy in my mind is the equivalent to like the HTTP spec. It's just words probably written in English that humans can read, and it just describes what the pieces are and what they should look like and how we interface with them. Just how CNI is effectively like a blob of JSON that a plugin can run and return, information in a standardized way. I see Cosy being that for operating systems.
Okay, so the Duffy's pointing out there was a talk yesterday that doesn't interest us. I think that's Andrew, and I can't. He did a talk with someone else whose name is escaping me right now, but yeah, there was definitely a talk about it. Also, Duffy saying I like Doci. Marino suggesting how about a Doci?
So like... I think I can provide some clarity here. I had written a blog post a couple weeks, maybe a few months ago, that I called, this was when Andrew and I first started talking, I called it the distributed operating system interface.
Okay, right.
And I think, knowing Duffy, who is also casually like my neighbor, him and I talk a lot offline. I would assume he's talking about my blog here. And I think really what it was is I just wanted to call it something different so that I could describe an independent set of problems for the sake of a thought experiment. And then after talking with Andrew, we were like, yes, we have successfully both engineered the same thing independently of each other. That's kind of our use case and our proof of concept that this is something we should work on together. So TLDR, I think it's just a naming thing. And right. I think that names are hard. Yeah,
names are definitely hard. Yeah, you just have to hope that it isn't already kind of splitting off into different versions of the same thing. I don't think it is. I think it's,
Yeah, I think it's just, I called it something different in a blog. And like with anything with naming, like already there's other projects called Cosy. There's even one in Kubernetes that is like some other operating container object storage interface or something.
Okay.
So like, naming things is hard, but I think the idea remains the same, that like if we were to reimagine a world where operating system level concerns started to be built to a standardized interface such that we could, get things like the kubelet and CNI and CSI to interface with that, what does the driver story look like? What does the operating system look like? And what we call the actual definition. Like, I hate naming things. I don't know, we could call it whatever we want.
Naming definitely should be up there with, all the, I think it is up there with all the, most difficult problems in computing, like out by one errors.
It really is. Like, somebody just pick a name, like name it after your pet dog or like your favorite food or something. Like, we just need something to call it.
Call it Björn.
There you go.
The interface called Björn. That's fine. Yeah.
Right. Björn down that house.
Hi, Vineet. Nice to see another old friend. Excellent. So Grant asking, coming back to Cosy, would this be a translation of a common defined set of system calls that would then translate into the kernel specific interfaces? So I guess, is it a higher abstraction than the kernel specific interfaces? I mean, actually, that's a very good question. Is it all in users? Is this a user space interface?
Yeah, this is it. So you are all now starting to go down the thing that Andrew and I went down recently, which is, I think so. I think this is a user space level abstraction. And I think this is very concretely a user space level abstraction. And if you look at it, the kernel has a clean boundary. System calls, like those are well defined and heavily guarded. And that API is like, I mean, that's like the inner sanctum of modern day distributed enterprise computing. And then we have Kubernetes, which has now become yet another rock solid industry standard that compartmentalizes the layer above user space. And then we have poor old user space stuck in the middle, like the middle child, and doesn't really know who to do, like how do we route everything between what's going on in Kubernetes and what's going on in the kernel. And we do need routing there. There is a boundary there. There is things that happen in user space that we very much don't want to happen in Kubernetes land or in kernel land. And it's just the Wild West. You can do whatever you want, however you want, whenever you want. And we're just over here scratching our heads saying maybe we should start to standardize some of this as a community.
It's a really interesting point that if, we keep talking about Kubernetes as a distributed operating system, so we should have an understanding of how that fits in the kind of user space, kernel space language.
Yeah. And eBPF, like that gives us a means to an end, right? Like if we had a common set of standards for user space, implementing those standards with eBPF is now fun and easy, right? Like, and we can do it in a secure, quick way that we know can scale, and we can start to build those tiny, simple use cases and those tiny permutations as needed.
Speaking of eBPF implementations, Vineeth is asking if we're planning to write tools around eBPF, what are the preferred languages with eBPF utilities? Can I pick Rust over Go for building tools with eBPF? So I guess there's kind of two parts to this. There's the first part, which is that the kernel, the piece of program that's going to run as your eBPF program is going to be written in C. I'm not aware of anybody writing those parts in anything that isn't C. Please correct me, people who know better. But I think that's always written in C. But for the kind of user space part, you have, many options as far as languages are concerned, right? So I think when you've been working on some implementations for because I think you've got code in place, right, for like a Cosy implementation. What languages are you leaning towards these days?
Awesome. So this is a great question, and Liz, you pretty much hit the nail on the head with there's kind of two really important parts of eBPF. There's the actual teeny tiny elf object, which is a little .o file that then gets loaded into the kernel and can kind of chug along and do all of its little logic-y bits that it does. And then there's this happy userland program on top of it, and then that's where Go and Rust and all of these I hate to say it, but higher level languages become really interesting, and that's where you can start to craft really compelling stories like Psyllium, right? Like Psyllium, it's written primarily in Go. It'll compile these little C files and then it loads them into the kernel. But then we have this nice little Go program that will have a Go function to compile it, and we'll have a Go function to go and load it into the kernel. And then we have a Go function to read it from the kernel, and it kind of just makes that whole story a little bit more user friendly. So if you're doing the eBPF management, 100% would recommend something that you're quick and easy with, that has access to system call level libraries like Go or Rust. The load BBPF syscall is what you're going to be mutating, and getting things compiling and then sticking them into the kernel will happen that way. But yeah, if you're writing an eBPF program, that's usually a very small part of the bigger process, and that's usually written in C. And for Cosy specifically, Andrew is, I'm going to really embarrass him right now. He is a fantastic Rust engineer, and he's written a PID1 in Rust, which is available in that GitHub org that people were sharing in the chat. And that kind of solves the, what do we call from the bootloader? What does init look like? How do we start the process that starts other processes? And that's all written in Rust. And then, we can load eBPF programs that would be written in C from there. And then I wrote, as my kind of answer to Pig1, I did a C++ kernel module style implementation that kind of did the same thing. And I wrote that because I was just dealing directly with the Linux headers, and I had just been writing C a lot lately, so my brain was kind of already there. But yeah, I mean, in theory, you could pull this all the way up to JavaScript if running on a web page if you wanted to. It's just a matter of how do you orchestrate all the bits underneath. So like anything, it's kind of up to you. You just have to know when and where you want to hook into it. Anyway, sorry, go ahead, Liz.
Yeah,
I'm reading the chat now.
Looking back into the chat, there's a few people posting, links to the, actually on eBPF.io, there's a list of libraries. So libraries that you can use to write those kind of user space components, and like Nova was saying, the kind of access to those syscalls, giving you a nicer abstraction around those. And it doesn't have to be a compiled language, right? There's BCC that uses Python, and you can write, get your eBPF code running in a very few lines of code with some of these libraries. Michael saying Go is more fully baked, but he'd been using libbpf rs with Rust. more work to do on it to make it as stable as BPF to go, in his opinion.
Yeah.
Seems fair. Okay. Lewis is offering the code name Ramen Bear if you know there are still there must be some kind of in-joke there. I don't understand.
I love the idea of just offloading names to things that are almost meaningless, because then like at least we in a weird way that's the best name, because then we don't argue about it. It's just like we just named it after ramen and that's what it's called. Moving on with our life now.
Yeah, why not?
Yeah.
Psyllium, I mean, you know.
Yeah.
I don't know. I feel like Psyllium should be an element in the periodic table, but I don't actually think it is, but maybe it should be.
Oh, I wish my girlfriend is like a huge like physics, like science person. Okay. She would just know this off the top of her head. I wish she was here because she would be telling us right now.
I was having a conversation with some friends the other day, and they were all sort of remembering their mnemonics for like how they remembered bits of the periodic table, and I can only remember about 4 elements. It's a bit embarrassing, but
oh yeah. Oh, so the Psyllium is the plural of cilia. It's an organelle found on eukaryotic cells. It's like an eyelash for cells. It's just like this little, almost like the outskirts of a coronavirus would look. That's cool. I just Googled it really quick while you were talking.
I'm not sure that's an image we want. All right. Christopher is posting, he's posted a link to that PID1 project. So I don't know if that's the, oh no, that's the Rust one. Yeah, he did say. So great.
Yeah.
Thank you for that. And Psyllium relates to cilia, tiny hairs in your ear. I'm going to guess that maybe it's tiny hairs, basically.
Yeah.
Don't know quite how that got translated into a name for a networking plugin. That's probably a question I should have asked, but yeah, just ask it publicly now.
There you go.
All right. So, oh, I don't understand that question. What's the difference between Celio and Psyllium? Yeah, this is a very weird time to join this broadcast. All right. Yeah. So, what do you think the future is going to be for this Cosy project? Like, it seemed like
the future
were interested in the idea from the talk at KubeCon.
So I guess there would be a few things I would say. Like, I have my own personal definition of what success would look like to me. And I'm hoping to share that idea with others. And then I also have there's the normal, doodles and docs, right? Like how do I get involved? When's the meeting? Where do I sign up? How do I start to come and become a part of it? So I would point out both of those things, which for me, it's like, if we just have components that almost like Linux from scratch, but let's apply the cloud native style of, compartmentalization and interface design to that. If we ever get to a point where we can, I can change my PID1, like I can change my trousers in the morning. That to me is success criteria for the project. And then I guess if folks want to get involved, there's that, I'm sure somebody can drop a link in the chat. There's a community page that we're trying to do a weekly call, and we're just trying to do really open source, kind of everybody's welcome. And we believe that collaboration is more powerful than competition. So I would just say that if this seems like something you are interested in joining, then we would love to talk to you and hear from you and see if it made sense to build any of this together as a team.
So you have your day job at Twilio, you have open source projects like Cosy. Are you still finding time to climb up some mountains?
That is a fantastic question, and I'm so glad you asked that question, Liz. So honestly, I am still climbing. I'm considering doing a climb on Sunday. The caveat is I do have the new puppy, and he's introduced a few set of boundaries with travel and with mountain climbing. So I'm strongly considering taking him on his first mountain climbing adventure, and that's going to yield a tiny, adorable puppy in my backpack on the top of a mountain. And I really hope that I can bring this imagery to life. And then I hope that like he becomes a trusted mountain climbing friend of mine. You know, I used to have a dog who used to go climb with me, and it would be really nice to have a buddy again. So I'm very hopeful. I'm a
I hope
hopeful
he's
person.
got a head for heights. Yeah.
Yeah. So we'll see. Hopefully it goes
Yeah.
well.
Yeah. And are you in sort of Seattle area these days?
I am everywhere and nowhere all at the same time. I'm like eBPF in real life. No, I am this house that we're in right now is in California,
Okay.
and I have a feeling, and this is very new information, but I have a feeling I'm going to be moving in the coming months. I have a surgery next week that I'll be getting, so I'll probably be kind of offline for a while, and then I might kind of reemerge in a different part of the world. We'll see how it goes.
Oh wow. It's like I feel like there's a game where things disappear and then reappear somewhere magically and
Yeah.
unexpectedly. So, well, if it turns out you are moving to London, we will definitely welcome you here. But I'm sure
Okay.
there'll be a eBPF community, hopefully wherever you land.
I would love to come back to London. Honestly, I used to fly United Airlines, and BA was a big part of my old like what I used to do. And I got a phone call from them, and they were like, "So you know, Miss Nova, we've looked, and London was your #1 travel destination for
Yeah.
3 years in a row, and you haven't booked any flight." And this is like in the middle of a global pandemic, and I'm like, "Well, I wonder why I
Yeah.
haven't been flying to London." But yeah, I mean, I didn't realize how much I had gone to London until that phone call, and I went and looked at it, and like I had gone to London maybe 20 or 30 times.
Oh
Maybe I
wow.
should just get a
Yeah.
place there. Yeah.
Yeah. Well, it's a hub for the cloud native community, I would say, but and
That's
you're always
great.
welcome
Yeah.
here anytime. So I think we're pretty much running up to time. I'm going to say if anyone has any last minute questions. So actually, Yarin has come in with a question: what's the difference between Calico and Psyllium? I'm going to say that is a question that is, I mean, they're both, Kubernetes networking plugins. They newer versions of Calico do use eBPF, so there are some similarities. They both enforce things like network policy with slightly different approaches. There is probably a very long set of similarities and differences that I don't know all of by a long stretch. But I would say if you go onto the Psyllium Slack channel, there will be people who can answer that question really fully and give you a more sort of detailed and nuanced answer. But they're both networking plugins, so at some level they're kind of ticking the same box. But obviously I am biased and I prefer Psyllium. All right, the way they're spelled. All right, so Kris Nóva, thank you so much for spending time with us today. Thank you so much for introducing us to the most adorable fluffy dog in the world, who I want to have back on eCHO again, because I want to have you back on eCHO, but I also want to have furry animals. Be awesome. Come and see us in London when you can, and everybody, Popcast is here. Hi Dan. Awesome. Thank you everyone who's joined us today. Wonderful to have you on the chat. Thank you for your questions. Thank you everyone who has been participating in KubeCon as well. I think I've seen a lot of you online there, and that's been great. I have really enjoyed. It's not the same as like the in real life conference experience, but it is lovely to get to interact with people online. So next best thing. Thank you so much, everyone.
Yeah.
And you've got any last words or anything you want to add?
I was just gonna say that it was great seeing you. I feel like this is the first time in maybe a year I felt like I've gotten some like one-on-one time with Liz again, and it kind of feels like old times. It's been great.
Yeah, it's lovely. Awesome. Thank you again. Everybody have a wonderful weekend, and we'll be back next week with another episode of eCHO. Bye.
Bye.